Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all participants. I hope all of you had a great weekend and ready to listen to this webinar. Thank you very much for joining this session. My name is Roslinda binti Fauzi, and I will be your moderator for today. Okay, the title for this webinar is Enhancement of Hybrid Carbon Black Nano Calcium Carbonate Filler Performance on Natural Rubber, starting Untitled Rubber blend properties via silane treatment. Okay, before we start our session, allow me to introduce our honorable speaker. Dr. Liyana started her tertiary education with diploma for 6 months at UiTM Kuala Pilah Negeri Sembilan. She continued her diploma and bachelor's degree in the Polymer Technology program at UiTM Shah Alam Selangor and excelled as the top student there. Upon graduation, she was offered a scholarship under Young Lecturer Scheme from UiTM for her PhD in 2014. Her PhD is specializing in the modification of thermosetting epoxy resin. She was then assigned to the Department of Polymer Technology at Faculty of Applied Sciences UiTM and joined the Center of Polymer Composite Research and Technology for PRESS, Institute of Science, as an associate member before being promoted to fellow. Dr. Liyana has supervised more than 20 undergraduate projects, be appointed as supervisors, and panel of examiners for postgraduate students. With her experience in teaching rubber compounding, polymer processing, and rubber elasticity courses, encourage her to pursue more knowledge on the latest development in that area. Her research interests include the modification of epoxy resin and composite systems. Apart from that, she also involved in rubber fields where her research focuses on rubber blends, incorporation of hybrid filler, and reclaimed rubber projects. So without further ado, I will pass the screen to Dr. Liyana. Dr. Liyana, the floor is yours.
Okay, thank you, Madam Roslinda. Assalamualaikum warahmatullahi wabarakatuh. As mentioned by moderator, my name is Siti Mamauod. Today, I would like to share some findings from my previous study, which conducted by my student. The title of this slide is Enhancements of Hybrid Carbon Black Nano Calcium Carbonate Filler Performance on Natural Rubber SBR Blend Properties via silane treatment. This is a presentation outlines of my slide that consists of introductions, target of our study, methodology, result, conclusions, and publication. Okay, in the introduction sections, I will focus on the rubber blend, reinforcement, and surface treatment. Okay, rubber blend. A rubber blend is a mix of two or more rubber that have been blended together to create a material with different physical and mechanical properties. Blending is an effective technique to achieve the industry need for a specific set of processability, physical and mechanical properties, and also the cost of a rubber product. Natural rubber and styrene with rubber SBR have numerous technological, environmental, and commercial advantages that are blended together to obtain a material that optimizes the mechanical properties. In this research, natural rubber was blended with the SBR at a fixed ratio and used as a rubber matrix. For your information, although natural rubber and SBR is known to exhibit numerous outstanding properties, filler need to add in the rubber matrix to enhance the vulcanizing properties. Okay, we can see that this picture shows that the polymer chains of SBR and NR that was blended together to produce a single rubber blend. Okay, a wide variety of particulate filler are used in rubber industry for various purposes, of which the most important are in reinforcement, reduction in material cost, and improvement in processing. And then move to the reinforcement. Reinforcement is primarily the enhancement of strength and strength-related properties. The presence of filler in the rubber blend would give a reinforcing effect and enhance the vulcanizing properties of rubber blend. In most applications, carbon black had been used as a main reinforcing material that increased the usefulness of rubber. Okay. When carbon black is compounded with rubber, the properties of vulcanizing are increased. For this reason, carbon black has been extensively exploited use in numerous rubber engineering products. However, the usage of carbon black in the rubber industry have certain inherent deficiencies, which are difficult filler dispersions, environmental pollution, and health hazards. Another filler that I used in this research was calcium carbonate, CC. CC filler are from mineral base, and nano size of filler are used in rubber due to the better reinforcing effects on improving the properties of vulcanizing. In this study, we can see that hybrid filler consists of carbon blacks and nano calcium carbonate were incorporated as a reinforcing filler in natural rubber and SBR blend. In the hybrid filler system, the filler combine their good properties to increase the vulcanized properties due to the synergistic effects of dual filler, resulting to the enhancements of a rubber product. The difficulty of hybrid filler to disperse in the rubber matrix cause deteriorations of vulcanizing properties. The picture show that the image shows that the aggregations happens in the rubber matrix due to the filler interaction that cause deteriorations of the vulcanizing properties. So in order to overcome this issue, surface treatment was introduced in this research, where hybrid filler surface was treated using silane coupling agent to enhance the dispersions of the filler in rubber matrix and improve the interactions between filler and matrix faces. By using this type of silane coupling agent, it also provides the flexibility properties to the vulcanizing. Here we can see that filler interact with the polymer chain, and then between the filler and matrix rubber faces, it consists of silane coupling agent that enhance the diffusion between filler and matrix faces. Okay, this study highlights the effects of different concentrations of silane treated hybrid, carbon black, and CC filler on cure characteristics, crosslink density, and mechanical properties on the natural rubber SBR blend. Okay, in the methodology sections, there are some main ingredients that are used in this research, which were natural rubber, styrene butyl rubber, SBR, carbon blacks, nano calcium carbonate, and silane coupling agent. In this research, natural rubber was blended at a fixed ratio with the SBR. It's about 60 pHR of natural rubber and 40 pHR of SBR. This rubber blend was reinforced using treated carbon blacks and nano calcium carbonate at a fixed ratio, about 50 pHR of carbon blacks and 4 pHR of treated nano calcium carbonate. As we can see that in these sections, it can divide it into two. It can divide into two, Part A and Part B. Part A is focusing on the preparations of treated carbon black and nano calcium carbonate fillers. And then the treated hybrid filler was used as a reinforcing material in Part B. The Part B is focusing on the preparations of the treated hybrid filler reinforced natural rubber SBR blend using a 2-row mill machine. Okay, result. Cure characteristics. Cure characteristics was conducted. It required to conduct it to identify the optimum cure time and the thought of vulcanizing. Cure characteristic was measured by conducting the cure test using a rheometer machine. This is the graph of the cure curve. There are some data can be obtained from this curve, which are minimum torque, maximum torque, maximum torque, optimum cure times, and scorch time. By using this raw data, we also can calculate the data torque and cure rate index of vulcanizate. As you can see that this table shows cure characteristic of the vulcanizate. And here we can see that this HFRB is referred to hybrid filler. 0 is referred to the untreated hybrid filler that used as a control in this research. HFRB 2, 4, 6, 8, and 10 is indicate the hybrid filler that was treated at a different concentration of silane coupled agent that I mentioned before, from 2 weight% to 10 weight%. Okay, as we can see that minimum torque is referred to the stock viscosity, which indicate the possibility of rubber compound. Maximum torque is a measure of crosslink density. Data torque is the difference between maximum torque and minimum torque, which indicate the formations of crosslink between molecular chain and reinforcement by the filler interactions, by the filler rubber interactions. And then optimum cure time is the time that required for material to fully cure. As we can see that the value of the data torque for the untreated hybrid filler is about 13. When we reinforce rubber blend with a treated hybrid filler, we can see that the increment is about 30.7. The gap, the differences between these values is about 135%. And it shows that the treated provide better or higher impact to the data torque value. And as we can see that the data torque increase has the silane concentration increase. And we can see that 4 weight%, we can see that HFRB4 provide the highest value of data torque. And it indicates that a higher linkage form between filler and rubber matrix phases. And apart from that, as we can see that this value indicate a good interactions between and treated hybrid filler form between both of them, which hinder the mobility of macromolecular chain in the blend, hence increase the value of data torque. And up to the silane phase, the data to decrease due to effect. And then as we measure time, we can see that silane coupled agent does not affect so much on the optimum cure times, and that value is not too different, about 1.314. We say that approximately same. Okay. And then move to another result is the crosslink density. Crosslink density is measure the development. It's referred to the development of the 3D network that form in the vulcanizate. And the important parameter affecting the development of the 3D network in this research is surface activity of filler. Okay, crosslink density was obtained by conducting swelling measurement technique, and Florey-Rainer equilibrium swelling was used to calculate the crosslink density that develops in the vulcanizate material. Here we can see the picture how the swelling measurement technique was conducted, where the vulcanizate material was immersed in the specific solvent, and the weights of the sample was recorded until it reached the saturation level. And as you can see that the crosslink density of the vulcanizate at 4 weight% of silane concentrations, it provides the highest value of crosslink density. And why it happened? Because of the at these concentrations, it provide or we can say that the existence of sufficient surface activity on the hybrid filler surface in the rubber blend would provide a stable microstructure for the filler to well disperse and hence increase the crosslink density. And then up to this concentration 6, 8, 10, we can see that the reduction trend, and it happened due to the self-condensation of silane, resulting in the formations of polysiloxane molecule on the hybrid filler surface. And this polysiloxane molecule acts as a plasticizer in the vulcanized sample and hence reducing the crosslink site between both rubber and metric faces. Okay, tensile strength. Okay, tensile strength of rubber indicate how much force or stress a rubber material can withstand before fracture. And we can see that 4 weight percent of silane concentrations provide high tensile strength due to the high crosslink density. High crosslink density that form in the vulcanized cause to the formation of more chain segments that make the vulcanized unable to support higher tensile force. And then the reduction of tensile strength at up to 4 weight percent of silane compressions was due to the plasticization effect. Okay, elongation at break. Elongation at break refers to the ability of the material to elongate before its fracture. And as we can see that the elongation at break directly proportion with the silane coupling agent. Increase the silane coupling agent will increase the elongation at break. And why the elongation at break increase? Okay, the elongation at break increase due to the plasticization effect and the flexibility rubber network that formed in the vulcanized that make the system become elastic. Okay, the plasticization, for information, the plasticizations happened due to the excess of silicization, due to the excess of silane coupling agents, and this silane coupling agent will cause the linkage that form between rubber and filler faces become weak, and hence the elongation increase. And then this is a result for the degree of reinforcement. Degree of reinforcement indicate how strong the linkage that form between rubber and metric faces. DOF can be calculated by dividing M300 with the M100. M300 is referred to the elongation modulus at 300 elongation, and M100 is referred to the modulus at 100 elongation. As you can see that the degree of reinforcement for 4 weight percent of silane coupling agent that used to treat hybrid filler surface provide the highest DOF due to the strong interactions between filler and metric faces, which make the vulcanized become stiffer and rigid. Okay, and up to this value, we can see that the DOF start to decrease due to the self-condensation of silane, resulting in the formations of mono and polylayer of polysiloxane molecule that I mentioned before. Okay, which act has this polysiloxane molecule that presents on the filler surface would act as a plasticizer in vulcanized. Okay, this is the publication. This is the publication that has been done. The result that I mentioned before were published in this paper. Okay, conclusion, I can say that by conducting surface treatment using silane coupling agent on the hybrid filler surface would enhance the surface activity of filler and improve the interactions between rubber and filler faces, and also strengthen the reinforcing effect with the rubber blend. At the optimum concentrations of silane coupling agent, it would provide or produce the maximum interaction between filler and metric faces, thus resulting increasing the performance of vulcanizing. Okay, this is a current research that I involved in with focusing on the reclaimed rubber. Okay, I think that's all. Thank you.
Okay. Thank you, Dr. Liyana, for a very interesting presentation. I think we have more time for Q&A. Now I open the floor for Q&A session. Okay, you may speak up your opinion. You can write your question in the chat box. Okay, we just take only half an hour to finish this presentation. Now we have around 20 minutes for Q&A. Participants who have any questions, you may on your microphone and ask Dr. Liyana, or you may write your question in the chat box. Okay, while waiting for the question, I myself have two questions, Dr. Liyana.
Okay.
My first question is it possible to use other techniques or treatments to overcome the agglomeration of filler in laboratory?
Yes, it's possible to use other technique or treatment to improve the dispersion of filler and matrix phases. One of the simple technique that can enhance the dispersion of the filler in rubber matrix is by adding some sort of computerizer that increase the dispersion of filler rubber matrix interactions. Okay, apart from that, you also can use alkaline solution to treat the surface of the filler. However, this type of solutions can enhance the filler dispersion in the rubber matrix, which is it not improve on the mechanical properties, just on the dispersion of fillers to produce a good filler rubber infection. Okay.
Yeah, all right. Okay, Dr. Liyana, thank you for clear explanation. But I have another question. This is my second question. As mentioned in the presentation, surface activity of filler is one of the main parameters affecting the interaction between rubber and filler. Okay. What are the factors influencing the reinforcement of filler in vulcanizing? Can I get explanation from you, Doctor?
Okay, as mentioned in this research, one of the factors affecting the filler matrix, the degree of reinforcement is surface activity. Another factor that affects the degree of reinforcement is particle size and space area. The bigger the particle size of filler that you use, the more the particle size that's exposed to the filler rubber interaction that cause to the vulcanizing property. Apart from that, the topology also influence the degree of reinforcement between rubber and matrix phases. If we have a rubber particle that have a rough and smooth surface, rough surface of the filler particle provide better interaction with the filler matrices that cause the increments of the vulcanizing properties.
All right. Okay, Dr. Liyana. Since we have a few participants who just joining this webinar, can you give an overview of your project for the newcomer participants understand what this presentation is all about?
Okay, actually this project is focusing on the effects of the effects of surface treatments on the rubber blend, which in this research we are focusing on the natural rubber and SPR rubber blend, and due to the dispersion issue about the filler in the rubber matrix, so the surface treatment was introduced in this research, where a different silane concentration was used to treat the hybrid filler in order to enhance the interactions between filler and matrix surface, and also to improve the dispersions of the filler in the rubber matrix so that the vulcanizing performance would be increased.
Okay. I hope the participants who just joining this webinar can understand the overview that Dr. Liyana just delivered just now. Okay. Since we are waiting for some questions from participants, may I get clarification from you, Doctor? What are the methods to hybrid the That's my question. Okay, in the title, stated that you are now hybrid the carbon black and nano calcium filler, right? So
Yes.
what are the methods to hybrid that two materials? Meaning that the method to hybrid carbon black and nano calcium carbonate filler.
Okay, as I mentioned before, there are a few techniques or methods that you can use to hybrid the fillers in the rubber compound or any types of material. Maybe you can use a simple mixing process where the computerizer or coupling agent, any type of coupling agent that you can use to enhance the performance of the filler in the rubber matrix that cause or leading to the enhancement of the vulcanizing properties.
Okay. Other than carbon black and nano calcium carbonate filler, what kind of material that can hybrid? My field is polymer synthesis, not in rubber. So may I know what kind of material that can hybrid other than carbon black and nano calcium carbonate? Can you give some examples?
I think there are lots of filler that you can hybridize together. In this research, as I mentioned, carbon black with the nano calcium carbonate. But then you also can hybridize another type of filler such as using fiber, natural fiber, let's say silica with the carbon black, silica with the calcium, calcium with the calcium carbonate, and many more you can add. But the most important thing, before you choose this type of filler, you have to identify the properties for each filler that can give the impact to your research.
So meaning that there are a lot of filler that can be hybridized other than carbon black and nano calcium carbonate, Dr. Liyana.
Yeah.
I see. So, okay, we have another question from our participant. Okay, Assalamualaikum, Dr. Liyana. My question is there any interaction within the filler itself since you are using two types of nanofiller?
Okay, it's about the interactions. As I mentioned, the interactions between filler phases happen basically due to the surface activity on the filler. For example, the carbon black, the surface of the carbon black consists of OH group, and then calcium carbonate also OH group. The possibility due to the same polarity, these fillers tend to interact between them and form agglomerations. Okay.
Okay.
Mm-hmm.
I think Dr. Liyana has answered the question. Okay. We still have more time actually. Okay, but then do you have any information to add, Dr. Liyana, from your research? Maybe you want to add some information or to share some knowledge with our participants before we end our session?
Okay, just to share with you, as I mentioned, I current research that are involved is focusing on the declaimed rubber, and then I study how the declaimed rubber can be added into the general good rubber product to reduce the cost and also to improve the vulcanizing properties, so that we can reduce or overcome the excess or the waste material in the world.
Actually, one great project, Dr. Liyana. Okay, we have a continue question from Iman. She said that but agglomeration will cause problem with the performance. Okay, maybe this one is this is the what we call it, but the agglomeration will cause problem with the performance. But maybe this is the continuity from her question. Can you answer on that, Doctor?
Okay. Can you repeat? Meaning that
the agglomeration will cause problem with the performance.
Yeah, because of actually the performance or the performance is referred to the vulcanizing properties. So if the rubber matrix, if the filler cannot well disperse in rubber matrix, so it cause reductions of the tensile strength. As we know that the functions of filler is to increase the strength, the strength of the vulcanizing properties. If the material, if the filler cannot well disperse and have a good interaction with the rubber faces, of course, it causes a deterioration of the vulcanizing performance.
Okay. I hope that the answer from Dr. Liyana will satisfy the last question. Okay. Alright. If participants have any other questions or you need detailed explanation from Dr. Liyana, you may email to Dr. Liyana straight away. You may find the email address in the chat box along with the attendance link. I have posted attendance link for your training hour. Okay. Thank you, Dr. Liyana, for your detailed explanation and interesting sharing.
Thank you.
All right. We are about to end our session earlier, I think. Or do you have any information, Dr. Liyana?
I think that's all.
That's all.
Yeah.
Okay, Dr. Liyana. Okay. So, but then before I end this session, I have a short poem to share with all of you. Classes came, classes went. It's worth a lot the time we spend. Okay, with that, I end this session with Assalamualaikum warahmatullahi wabarakatuh.